Hi everyone, welcome back. So today we're working on another group problem. Well, being honest though, you're probably watching a YouTube video right now, and so thus they're most likely alone. Hey, but maybe you're watching with a whole bunch of friends because you just love these videos so much. Or perhaps you've got a dog or a neighbor nearby. Ask them for help. Maybe they just love engineering problems. You never know. Friends. Boom. Okay, with that being said, let's jump right into this. Now what are we given? Well, we've got a beam right here. And it's got a little member right there. And there's a 400 Newton force. We're trying to figure out what the internal forces are at point C. Okay, so what are the internal forces at point C? How are we going to do this? Well, let's find out. So first off, we're going to need to determine all of our reaction forces. So reaction forces are right here and right here. We've got a 400 Newton force right here. And you're like, what about this rope? That's part of this frame. Okay, that's part of this frame. The rope doesn't mean anything until we cut it. If we want to figure out what the tension in the rope is, we can do that. But for now, the rope doesn't do anything since it's part of this overall structure. It would be like saying, well, the force right here. There's no force right there. Now, how are we going to solve for this? Well, I would probably do some of the moments first. Do it around point A, get rid of some unknowns. I can solve for By pretty simply there. So, they don't quite do that. They do some of the forces in the x direction first, which also works. We've only got one force in the one unknown in the x direction, so it has to be equal to 400 newtons just going that way, which is why it's got a negative sign. As a note, I strongly suggest that you always make these arrows point in the positive direction just to begin with, because then you don't get confused. If you plot them in the negative direction to begin with, you're like, wait a second, I got a negative of a negative. What's going on here? Just don't do that to yourself. Point them in the positive direction, and then go from there. So we do our math. First we solve for AX, then we take the sum moments around point B to solve for BY. Try to solve for AY, so we only have one unknown there now. And let's look at this right here. So we have negative AY times 5, because that is clockwise, and this one is also clockwise. Remember, I always suggest that you draw it in such a way that you're kind of getting the idea of how it turns. Draw from the point you're taking the moment, go over, when you hit the force arrow, go in that direction. What direction are you turning? Well, I am turning clockwise. I'm turning clockwise here too. So clockwise is usually considered negative. It doesn't have to be. You can make it positive if you want to. Just be consistent. And I do that. And when I solve, I get AY with negative 96 newtons. So this one's actually also going the wrong direction too. Okay, let's keep going. So now we slice at point C. When we slice at a particular point, what do we get? We get three forces. We get a shear force, a normal force, and a moment. That's the three forces, sorry about that. And a moment, a couple moment right there at the end. And these all have to balance out. It has to balance out, otherwise it is not in equilibrium. So, to do that, it's not really difficult to solve. We look and we see, I can see what the normal force is going to be. I can see what my reaction force is going to be. With a couple moment, what's that going to be? Two of these are very obvious. The last one is also pretty easy. 96 newtons at a distance of 1.5 meters, that causes a moment. I go like this, I go down, and it's a positive one. However, you can see that both of these are going in the positive direction, so I have to add both of them. And so MC would be negative 144 newton meters, which means I actually drew it in the wrong direction. It should have been in this direction, and then I would have been good. That would give me my moment. But with this, we get all of our forces at point C like we wanted it to. It wasn't too terribly difficult. Now going back here, you just have to remember that this rope right here, even though it looks like it should be doing something, it doesn't do anything if all we care about is a force over here. This rope is a part of the frame. Since it's a part of the frame, it doesn't have any other forces acting on it. It doesn't do anything special. That's an internal force. We don't write internal forces unless we're cutting it to find what it is. So, thanks for listening. I hope this helps you, and I'll see you all next time. Bye-bye.